arc length and area of a sector. Arc length. We know from the definition of radians that 1 radian, theta radian, is nothing else but the ratio of the arc length over radius. This one is arc length over radius. So now when I multiply both sides times r, multiply times r, this cancel out, and this would be r theta. So my arc length is r times theta. So we have that the arc length is equal to r times theta. So this one is the arc length formula, r times theta. Very important that theta must be in radians. In order to use this formula, that arc length S is equal to radius times the theta, theta must be in radians. Very important. So an arc subtended by a central angle of theta radians is given by that this S is equal to r times theta. That's the arc length formula. And now we have example 1. Given that S is the arc length, r is the radius of a circle, and theta is the angle, find the missing quantity. And we have A, that r is 5 meters, theta is pi over 3 radians, and we are looking for the arc length. So first what you need to do is to check if your theta is in radians. In that case, my theta is in radians. So now I can apply the arc length formula. I substitute that the arc length is r times theta. So my r is 5 times theta is pi over 3. So 5 is like 5 over 1. So I have 5 pi over 3. That's my arc length, and it's the same as the radius is in meters. Or we can punch this on calculator and get the approximation. That this one is 5.232598 meters, or roughly 5.2 meters. Okay, the arc length is 5.2 meters. Example B. We have that the arc length is 2 feet. We have that the theta is 2 radians, and we wanna find the radius. So we use the arc length formula. S is equal to r theta. We substitute what we have. We have 2 feet is equal to theta's in radians. So we have r times 2. And then we can solve it for r, or we can write that this is r is 2r. To solve for r, we divide by 2. This cancel out. So my radius is 1, and the unit is the same as the arc length, 1 feet. Example C. We have the radius is equal to 3 centimeters. Theta is 210 degree, and we need to find the arc length. So since our theta is in degree, first we need to convert it to the radians. So convert theta into radians. Because the arc length formula uses only theta angle in radians. So we are using proportion. 100 degree is pi radians, and 210 degree is my x radians. We can make the proportion from that. Now we can cross multiply. 180 times x, 180x is equal to 210 pi. Now we can divide by 180. Divide by 180. So my x is equal to, we can reduce those zeros right away. So we have divide by 10, so 21 pi over 18. And 21 pi over 18 we can divide by 3. Divide by 3, divide by 3. So we get that x is equal to 7 pi over 6 radians. So my theta is 7 pi over 6 radians. And now we can use the arc length formula. The arc length formula says that is r times theta. So this is equal to 3 times 7 pi over 6. 3 and 6, 3 is like 3 over 1. 3 and 6 reduces to 2. So the arc length is 7 pi over 6 centimeters. Or if we want to get the approximate value, 7 pi over 2, 7 pi over 2 centimeters. Or if we want to get approximate value, then we can multiply 7 times pi. So the approximate value is that this is 10.99557 centimeters. So this arc length is approximately 10.11 centimeters. Now we would like to talk about area of a sector. Area of a sector. Area of a sector of a circle with radius r formed by a central angle of theta radians is given by, so the situation is like this. I have circle and here is my arc, here is my angle. So I'm interested in this area of this sector. Okay, so the area formula is that the area is equal to 1/2 r squared times theta, and of course theta must be in radians. Theta must be in radians. So the formula roughly comes like this. You can think, how did we get the formula? The formula roughly comes like this. The whole area of a circle is pi r squared, right? But now But now the arc length of the whole circle, the arc length, okay, so we have the arc, the angle. The angle theta is nothing else but 2 pi. But 2 pi. If I solve for pi from this, I divide by 2, so my pi is theta over 2, right? And if I take this pi and substitute to this one, I'm getting the formula what we have. So the area is equal to theta over 2 times r squared, or we can write that the area is 1/2 theta r squared, or everywhere is multiplication. We can rearrange this in this form, that the area is 1/2 times r squared times theta. That's how this formula comes from. That the theta for the whole circle, the arc, the angle, subtends the arc of 2 pi, because the whole circle is 2 pi radians. And if you solve for pi, you get this one. Okay, so now example 2. Given that A is area of the sector, R is radius, and theta is the angle, find the missing quantity. And we have A. We have that radius is equal to 5 meters, theta is equal to 1/4 radians, and we need to find the area of the sector. Okay, so we apply the sector area formula, area of the sector formula. A is equal to 1/2 times r squared times theta. First check if your theta is in radians. Yes, it is, so we can apply it. So it's 1/2 times 5 squared times 1/4. So 5 is like over 1. So on top I have 1 times 5 squared is 25 times 1 is 25 over 2 times 1 times 4 is 8. So 25 over 8, and the same unit meters, area in meter squared. B, we have that the area is equal to 3 feet squared, and that the theta is equal to 2 pi, is equal to 2 radians, and r is missing, 2 radians. Okay, so I'm using the area formula, that this one is 1/2 r squared times theta. First check if your theta is in radians. Yes, it is. We can apply the formula. So area is 3 is equal to 1/2 times radius we are looking for, and times 2. So 2 is like 2 over 1. Radius is like over 1. So multiply that, this would be 1 times r squared times 2 over 2. So in other words, this 2 and 2 can reduce. So I'm getting that 3 is equal to radius squared. Take the square root. Whenever you take square root, put plus or minus, is equal to r. If you take square root of both sides, right? You can do plus or minus square root. Okay. So since radius is the length, so it must be positive. So radius is square root of 3, and the unit is the same, feet. C. Let's do example C. I have that r is equal to 2 inches. I have theta is equal to 60 degrees, and I have that area is missing. Find the area of the sector. So in that case, first check if my theta is in radians. No, it's not. So first thing we need to convert degrees to radians. How was it? We used proportions. We know that 180 degree is pi radians. And now I have 60 degree. I don't know how many radians it is. So use the proportion. We can cross multiply. 180 times x is 180x. 60 times pi is 60 pi. Divide by 180. Divide by 180. So 0, 0 reduces, and divide by 6. So I have that x is equal to pi over 3 radians. Okay, now I can use the area formula, area of the sector formula. So my area is equal to 1/2 r squared times theta. My theta is in radians. In order to use this formula, the theta must always be in radians. So I have 1/2 times radius is 2 squared and times pi over 3. First perform this square. So this is like over 1. So my area is equal to, on top I will have 1 times 4 times pi, 4 pi, over on the bottom I have 6, 2 times 3 is 6. Now we can divide this by 2, divide by 2, divide by 2. So I'm getting that this is 2 pi over 3. And the unit is the same as radius, so it's inch squared. So the area is 2 pi over 3 inch squared. Okay, now we have example 3. Find S is the arc length. Find S is the arc length and find area of the sector. Round to 3 decimal places. And we have A on the graph. We have the circle. And we have that the radius is 3 feet. And we have the angle pi over 4. Pi over 4 radians. So we need to find, so my theta is pi over 4 radians. My radius is 3 feet. So arc length S was r times theta. Theta must be in radians. My theta is in radians, so I can substitute. So this one is 3 times pi over 4. So this one is equal to, they ask us round to 3 decimal places. So use your calculator, and we have that the arc length is 2.356, and the unit is the same as the radius feet. Arc length is 2.356 feet. And now they ask also us to find the area of the sector. So area formula is 1/2 times r squared times theta. Always check if your theta is in radians. Yes, it is. So we have 1/2 times pi over 4 squared. Times pi over 4 and times radius squared, so this would be times 3 squared. Multiplication, we can switch the order. So I can write that this is 1/2 theta times r squared. Okay, so the area approximately is the area gives me 3.534, and area is in feet squared, rounded to 3 decimal places. Okay, now we have example B. Now we have example B. Now we have example B. We have the circle, and we have radius is 10 meters, and we have angle 80 degree. We have 80 degree angle. Okay, so in order to use the arc length formula, my theta must be in radians. So first thing we need to convert 80 degrees to radians. So I know that 180 degree is my pi. And now 80 degree, I don't know how many radians it is, so put x. Cross multiply. 180x is equal to 80 pi. Divide by 180. This cancel out. So my x is equal to 8. I divide by 10. 8 over 18 pi. And this can be reduced by 2. So it would be 4,9 pi radians. Okay. So that's my angle. Now I can go with the arc length. For the arc length, S is equal to R times theta. So my radius is 10 meters times my theta is 4 pi over 9, and we can get the approximate value. We can get the approximate value to 3 decimal places, so it's 13.963. 963, and its unit is the same as this, it's meters. Okay, 13.963 meters, and area is 1/2 r squared times theta. So this one is 1/2 times 10 squared times 4 pi over 9. So the area approximately is 69.813, and this would be meter squared. And now we have applications to word problems. Applications to word problems. Example 4. A pendulum swings through an angle of 40 degrees each second. If the pendulum is 20 inches long, how far does its tip move each second? Round your answer to 2 decimal places. So we have the pendulum. Keep swinging each time, right? So the pendulum, and it swings through an through angle of 40 degrees. And what do they ask us? And the pendulum length is 20 inches. So the pendulum length is 20 inches. This length is 20 inches. So what do we need to find? How far does this one swings? So we need to find this length. And this length is nothing else but the arc length. If I consider the whole circle, so this one is nothing else but the arc length. So we have that my R is 20 inches, and we have that the theta is 40 degrees. And the arc length is R times theta, but theta must be in radians. So first thing what we need to do is to change degrees to radians. So 180 degree is pi radians. 40 degree, I don't know, I put x. Cross multiply, 180x is equal to 40 pi. Divide by 180. 40 pi divided by 180. This cancel out. 0 reduces, and we can divide by 2. So this would be 2 pi over 9 radians. 2 pi over 9 radians. Okay, 2 pi over 9 radians. So now my arc length S is equal to R times theta. So R is 20 and theta is not 40. Theta is in radians. Theta must be in radians. So it's 2 pi over 9. So punch this on calculator and get the approximate value. This is like over 1. So we have 13.96 inches. Round your to 2 decimal places. 13.96, and the unit is the same, inches. Okay, for word problem, write the word answer. So how far does its tip move? The tip of the pendulum moves 13.96 inches each time. One more example with word problems. Example 5. A water sprinkler sprays over a distance of 30 feet while rotating through an angle of 135 degrees. What area of lawn receives water? Okay, so we have the water sprinkler. The water sprinkler keeps spraying 135 degrees. So it's kind of like this. And the water keeps spraying all over here. Okay. So what we have, that the water sprinklers over a distance of 30 feet. So my radius is 30 feet and my angle is 135 degrees. So this angle is 135 degree. Okay, so if I consider that this one is nothing else but a part of my circle, okay, but the part of my circle, so I'm looking for area of a sector of the circle. So my theta, my radius is 30 feet, and my theta, my angle is 135 degrees. 135 degrees. So in order to use the formula for a sector of a circle, for area of a sector of the circle, I need to first change the degrees to radians. So we have 180 degree is pi radians, and now 135 degree, it's my x radians. Okay, so we can cross multiply 180 times x, and then I have 135 times pi. Divide both sides by 180, and I have 135 pi over 180. Reduce, this certainly can be reduced by 5. Is 27, so it's probably even by more. So I'm gonna reduce by 5, reduce by 5. So this gives me 27 pi over 180 divided by 5 is 36. So this can be reduced even more, divide by 9. Now we can divide both by 9, divide by 9. So this gives me that my x is 3 pi over 4. 3 pi over 4 radians. So this one is my 135 degree is 3 pi over 4 radians. Okay, now I can apply the area of the sector formula. The area of the sector formula is 1/2 times r squared times theta. So the area is equal to 1/2 times 30 squared times 3 pi over 4. So the area is equal to 30 squared. 30 squared is 900 times 3 is 2700 pi over 2 times 4 is 8. And this we can reduce. This we can reduce certainly by 4. This we can reduce by 4. Reduce by 4. Now divided by 8, we can just divide by 8 and get the answer right away. If we divide by 8, does need to be by divide by 8, divide by 8. So we get the answer right away, that the area is equal to 337.5 pi, and the unit is feet squared. So we can multiply times pi, get the approximate value. That gives me 1060.287, so 0.29 feet squared. So what area of the loan receives the water? So the area of 1060 feet squared receives the water. And that concludes the lecture about the arc length and area of the sector of a circle. Thank you.